Okay, today we're going to learn about two factoring methods. The first one is factoring out a greatest common factor, or GCF, and the second one is factoring by grouping. So before we jump into that, let's talk about what factoring means. There's a couple different ways to think about factoring. One is that you're undoing multiplication. So if you factor, you're going to undo multiplication of polynomials. Okay, another way that I like to think about factoring is like breaking down a polynomial into smaller chunks. You're going to see what that looks like as we go throughout today and the rest of the unit as well. So the first kind of factoring that we're going to learn is greatest common factor factoring. So let's just review what a greatest common factor is. I'm not even going to write a definition because the word itself is kind of a definition. The greatest means the biggest. Common means something that two numbers have that are the same. And then factor is something that you use to multiply to get a bigger number. So say I want to find the greatest common factor of 4 and 10. Well, let's write the 10 underneath. One way to do this is to just list the factors of 4, right? Like 1, 2, and 4 are all factors of 4. And 10, we have 1, 2, 5, and 10 are all factors of 4. So then you look at these two lists of numbers and you figure out which is the biggest factor they have in common, and the biggest one is 2. So the greatest common factor of 4 and 10 is 2. Okay. You can do the same thing with variables. Like say I had 4x and 10x squared, right? Well, we already decided that between the 4 and the 10, their greatest common factor is 2. We can also think about that x is also a factor of x, and x are both factors of 10. So this x they have in common. So the greatest common factor of 4x and 10x would be 2x. So you kind of look at like the greatest common factor of the numbers as well as the the variables. Okay. So one more thing in this section is that we have something called a prime polynomial. So remember, a prime number means that you can't break it down. It doesn't have any factors besides 1 in itself. So a prime polynomial just means that it's a polynomial that can't be factored. You can't factor it, you can't break it down any smaller, you can't undo any kind of multiplication there. And we'll see some examples of prime polynomials throughout the unit. So let's jump into factoring out a greatest common factor. So let me just write a problem on the board, not on the board, on this tablet, so that we can work through it as we look at these steps. Actually, I'm going to get 3x squared plus 6x. So our first step is to identify a common factor. So I'm going to look at the 3 and the 6 and see what they have in common. So a 3, its only factors are 1 in itself. 6, the factors are 1, 2, 3, and 6. And then I'm going to look at the factors of the variables. So I have x squared and I have x. So the factors of x are just x and x squared, and of course 1 right at the end. And then the factors of x are x and 1. So then I see with the greatest common factor between the 3 and the 6 is 3. Greatest common factor between the x and the x squared is an x, which means that my greatest common factor is 3x. Okay. Next step is to put the common factor in front of a set of parentheses. So I'm going to take my 3x and I'm going to write it in front of a set of parentheses. Now I'm just going to figure out what goes inside my parentheses. What I'm going to do is step number 3. I'm going to divide the common factor out of each term. So I'm going to think about, okay, I have this 3x squared plus 6x. I'm going to divide both of these by 3x. Okay? And when I do that, I'm going to be left with x plus 2, right? Because 3x squared divided by x, all I'm left with after I divide out of 3x is just 1x. And if I divide 6x by 3x, I'm just left with this 2. So then I put that x plus 2. I guess that's my next step. I should write it in the next thing. My next step then is that I write the leftover terms in the polynomial, what happened after you divide it, inside the parentheses. Then 3x times x plus 2 is going to be the factored version of this polynomial. Now, another way to think about figuring out what goes inside these parentheses is think about, let's see, I'll do it right here. So I have 3x squared plus 6x, that's what I started with. I'm going to put a 3x out front. And I know I have some things I have to put inside. So for this first number, think about if I were to multiply, I'd have to distribute the 3x in. So what do I have to multiply this 3x by to get 3x squared? That's going to be x. What do I have to multiply 3x by to get 6x? That's going to be 2. So you can kind of think about it that way. What do I need to multiply the GCF by in order to get back to my original? Okay. So let's look at a couple examples of these. In the example we just went through, our greatest common factor had both a number and a variable, right? It was 3x. Sometimes you're going to have a combination of numbers and variables, and sometimes you'll just have a number or a variable. Like in A, x squared plus 3x. The only thing that these two terms have in common is an x. So I'm just going to pull an x out front, and then what goes in the parentheses is what do I have to multiply x by to get x squared? Well, that's going to be x. What do I multiply x by to get 3x? It's going to be positive 3. So that's it. Okay, let's look at B together. So B is pretty straightforward. We actually are only going to take out a number, greatest common factor. I have a -2 and a 6, and I recognize that they both are divisible by 2, so I'm going to factor a 2 out. And here's something special. Whenever your leading number right here is negative, factor out a negative. The idea is that the first number inside the parentheses is always positive. So then when I do -2y divided by -2, I'm just left with the y. When you factor out a negative, you have to be careful, because now if I have 6 divided by -2, that sign's going to switch to a -3. And again, you can always check this just by multiplying this number back in and making sure that when you multiply it back in, you get what you started with. Okay. So I'm going to let you guys work through a few of the next couple examples. I'm going to jump down to the bottom, and I am going to do H and I for us. These are kind of more complicated examples. Okay, so I'm going to jump down, like I said, and do H and I. So H looks super complicated. It's actually not as bad as you would think. So I'm just going to kind of handle each of the numbers and variables separate. So first I'm going to look at all these numbers, so the 2, the 8, and the 6. I'm going to say, okay, what do all of those have in common? What's their greatest common factor? And their greatest common factor is a 2. Then I'm going to look at all of my a's. So I have an a squared, an a to the 4th, and an a to the 3rd. So I have to see what they all have in common, and they all have at least an a squared, which means I can take an a squared out. And I do the same thing with my b's, b to the 3rd, b to the 8th, and a b. So they all have at least one b, so I can only take out one b. And then with my c's, I do the same thing, and they all have at least 4 c's, so I'm going to take a c out. A c to the 4th out, okay? Now it's just a matter of figuring out what is left over in here. So in my first term, if I multiply 2a squared b c to the 4th, the only thing I need to, like my 2's are already matched up, my a's are already matched up, I'm missing 2 b's. So I have a b outside and a b to the 3rd in my first term, so it's going to be a b squared. That's the only thing I have to multiply my greatest common factor by to get my original first term. Then my next term, I've got to multiply the 2 by 4. I need to have 2 more a's in there, so an a squared. I have to multiply a b times b to the 7th so that I get back to that b to the 8th. And then I've got to do a c to the 3rd power so that I get that c back to the c to the 7th. And the same thing with my last one, I'm going to have a 3ac. Okay? And one way to always check this is just to distribute your greatest common factor back in and make sure you got the right answer. You got what you started with. Okay? Now, I looks really weird. Okay, you might be tempted to start this problem by distributing the p and the 2 into the parentheses and then simplify. Let's not do that. What we're going to look at here is we have 2 terms. We have p times q minus 6 and 2 times q minus 6. And I'm looking for what they both have in common. And I noticed that both of those terms have a q minus 6. Okay, so I'm going to factor a q minus 6 out of both of them. If I factor a q minus 6 out of the first term, all I'm left with is a p. And if I factor out of the second term, all I'm left with is a 2. So then I can factor it just like that. Okay? It doesn't look complicated, but it's actually super simple. I is going to be really important. We're actually going to use the idea of this kind of factoring of I in our next kind of factoring method. Okay? Our next kind of factoring is factoring by grouping. Okay, so our step one is always to factor out a greatest common factor if there is one. Next, I split the polynomial into two groups with two terms in each group. Then I just look at each of the groups and find the greatest common factor of each group. Okay, so let's take a look at what that would look like. Let's just jump down and do A together. So first I check and look for greatest common factor, which this one doesn't have. Then I'm going to split this polynomial into two groups. Okay, each group has two terms in it. Then I just look at each group or each set of parentheses and find the GCF of each group. So in my first one, I have an x cubed minus 4x squared, so they both have an x squared in common. And then what's left over is just an x minus 4. And then in the second set of parentheses, again, I'm going to be adding right here because I'm kind of just carrying this sign down. In my second set of parentheses, I have a 3 in common. They both can be divided by 3. And I'm left with an x minus 4 inside. And this leads me to step 4. So hopefully the leftover pieces of each group, so this piece in the parentheses, the x minus 4, hopefully those match. In this case, they do match. And the reason we want them to match is because now we can do like we did in our last example and factor an x minus 4 out of each of the terms. So if I factor an x minus 4 out of this first thing, all I'm left with is an x squared. If I factor out of the second term, all I'm left with is a plus 3. Okay, so that's my factored form. So really factoring by grouping is just doing a bunch of factoring out GCF. Okay, let's try another one. I'm going to work through C. I recommend that you press pause and at least start C by yourself and see if you can do it. Okay, and then press play and just make sure that you're doing the same thing as me. So I'm going to divide this or split this into two groups. Then I'm going to factor the greatest common factor out of each group. So here I have 4y squared plus 4y cubed plus 2y squared. So I can factor out a 2y to the second power. And all I'm left with is a 2y plus 1. Lots of times people don't want to put a plus 1, but you have to remember that if you're going to multiply this 2y squared back in, and it's actually going to equal 4y cubed plus 2y, you have to have that plus 1. Okay? Then I'm going to look at my second set of parentheses and factor out the greatest common factor. Notice that here I have a bunch of negatives. Remember that I always want to make this first term positive. So I'm going to factor out a negative 3 because that's what they both have in common. When I divide negative 6 divided by negative 3, I'm left with a 2y. Then negative 3 divided by negative 3 is a positive 1. Okay. So again, I've got this nice thing where these sets of parentheses match, so I can factor them out of my polynomial. And then I just put the leftover pieces inside. So 2y squared minus 3. And that would be my final factored form. Okay. I'm going to start E for you. And then I'm going to let you finish it. So E is a little different because before I even start doing factoring by grouping, I can factor out a greatest common factor. So I look at all these numbers here and I notice that they're all divisible by 2. So I'm going to factor a 2 out. And it's not going to be grouping, it's just a greatest common factor. So I just divide all these numbers by 2. Right? And now I'm going to start grouping. So now I'm going to group the first two together, group the second two together. And now when I start factoring out greatest common factors of each, I'm just going to have this 2 that I already factored out. It's kind of just going to hang out in front for the rest of my problem. So the greatest common factor of my first set of parentheses is v squared, and I'm left with a 2v minus 7. Greatest common factor of my second set is a 3, and I'm left with a 2v minus 7. If it takes you a little bit longer to find your greatest common factors, that's okay. I've just been doing this a long time, so it's easy for me to recognize that's a GCF of 3. But sometimes you have to think about them a little bit more. Okay. I notice again that I have these nice sets of parentheses that match, so I'm going to factor them out. So I have a 2v minus 7, and then I put the leftover pieces together, v squared plus 3. And that'll be my final factored form. And notice that this kind of problem looks very similar to what I was asking you guys to multiply last unit. So last unit I would give you a problem like this and say multiply it out and then give me this long string of polynomials. Now we're just working the opposite direction. We're getting it down to factored form.